All right, we've been talking about random variables a lot lately, and we've also talked about how PMFs, probability mass functions, are appropriate for discrete random variables, while probability density functions are appropriate for continuous random variables. There's one last topic that you really need to know about random variables, and that's their expected value. The expected value of some random variable x is simply its long-term average. So if the random variable x is discrete, then its expected value, which we symbolize with this fancy-looking E, more specific than fancy-looking, this is called the Blackboard Bold font style. And yes, if our random variable is discrete, then its expected value is the sum over all of the possible values it could take on. So this is an italicized x. So we sum over and we multiply what those values are by the probability of having that particular value. We'll do an example of this in a second so that it's a bit easier to understand with the numbers. If x is a continuous random variable, then the expected value is the integral of the values x multiplied by the probability of those values. Let's dig into some numbers so that we can start to make sense of this. So let's start off with the discrete random variable situation. So I have a probability mass function here, a PMF. We've already seen this PMF a number of times in these videos. So now let's calculate the expected value of this variable. In order to do that, let's first calculate the probability of any one of the particular events. So the probability of having 0 heads amongst 5 tosses or 5 heads amongst 5 tosses, we already determined earlier in these live lessons that the probability of either of those outcomes is 1 in 32, which is about 0.031. The probability of having 1 coin be heads or 4 of the coins from 5 be heads, there's a 5 in 32 chance of either of these two categories, which is about 0.16 or 16%. And then finally, for the probability of having 2 or 3 heads, each of those is exactly 10 and 32. So you can add up 10 plus 10 plus 5 plus 5 plus 1 plus 1 comes out to 32. And that is a necessity. That's one of the characteristics of a PMF that we already described. So anyway, the probability of 2 heads or 3 heads is 10 and 32, which is about 0.31. So to calculate the expected value, we use this formula here. So sum up over each of these values multiplied by the probability of that value. And here's what that looks like. So for the first outcome, 0 heads, there's a 1 in 32 chance, and we multiply that by 0, by the value 0 in purple. And then we do that for each of the points. So for the value 1, there's a 5 in 32 chance of having that. For the value 2, there's a 10 in 32 chance. And then for 3, again, a 10 in 32 chance. For 4, a 5 in 32 chance. And finally, for 5 heads, a 1 in 32 chance. So multiply in each of these terms, sum up each of the terms, each of the 6 terms, and you'll get a value, an expected value of 2.5, which makes sense. It's exactly bang in the middle of this distribution. And so intuitively, that feels right, doesn't it? Let's jump into a hands-on code demo to see how we could do this a bit more quickly with code instead of calculating all of these values by hand. All right, so we're now in our expected value section of our probability Jupyter Notebook. And if you've been leaving your Colab session untouched for a while now, it might have timed out, in which case you can go up to the runtime and run all the cells before, and we can continue on as we were. So we've already run this code earlier, but let's run it again. So we ran the same code for an exercise earlier in these live lessons. So we already had the probability of any one of the 6 possible outcomes for our 5 coin toss experiment. So once we have these probabilities, it's a piece of cake to calculate the expected values, because we can simply follow the same formula that we had on the slides and that we worked through manually already on the slides. So here I'm using a list comprehension to iterate over all of the possible values of x, which are from 0 up to 5. And we multiply each of those possible x values by the probability of having that x value, which is represented by these probabilities here. So we can simply run this list comprehension, and voila, we get the 2.5 expected value that we also had when we calculated it manually on the slides. All right, feeling like you get expected values? Let's do some comprehension exercises to be sure.